Today we are going to look at rationalizing or using rationalization to find the limits of a function. So this function that we're looking at here, as x approaches 0, what's going to happen? Well, we know that we would plug 0 into all of our x's. That would become 0. And the problem with that is we now have a 0 in the denominator, and that function does not, it's undefined, so we can't have that. It doesn't work. So we need to find another way that we can do this, so that way we have a similar function that kind of mirrors this function, kind of rewriting this function, and we're going to use that to find the limit. So what we're going to do is we're going to rationalize this. We're going to play with these radical signs to see what we can come up with as far as doing that. Now, first thing I'm going to do is I'm going to use red for my scratch work. This is kind of the stuff that I might do off on the side of a piece of paper. It's not part of my formal equation here. But I'm going to say, let's let z equal the square root of x plus 1. Why am I doing that? All right, as I continue my scratch work here, that means if we are working with the fraction of, whoops, not that one. If we're working with this fraction, this fraction here, x plus 1 minus 1 over x, I have now made that z minus 1 over x. Well, that may not look like it's doing much or helping the situation, because now we've got two variables, but if I take z plus 1 over z plus 1, haven't changed anything, just multiplying by 1, that will give me z squared minus 1 over x times z plus 1. Well, great. What does that do for us? Well, if we plug our x plus 1 back, the square root of x plus 1 back in, we're now going to have the square root of x plus 1 squared minus 1 over x times the quantity, square root of x plus 1 plus 1. Okay, still may not look like much, but let's just move our page up a little bit. Still may not look like much, but let's continue with this. So the square root of x plus 1 squared, well, that's just going to be x plus 1, and that's going to be minus 1. So x plus 1 minus 1. And then we have x times the quantity, x plus 1 plus 1. All right, now I could distribute that x over the denominator, but look at this. We're going to have x in the numerator, and we're going to have x in the denominator, and we're going to have that x as a factor of the denominator, so we know that those things are going to be able to cancel out. That's going to go away. So we're left with a new function that's based on the old function. Nothing has changed. We've just multiplied by 1 to make all of this happen. But now, as x approaches 0, we go back up to our limit up here. We know that our limit as x approaches 0, we know this is an equivalent function now as x plus 1 plus 1. So as x approaches 0, we're going to have 1 over the square root. Let's try this again. We're going to have 1 over the square root of 0 plus 1 plus 1, which is 1 over 1 plus 1, which is 1/2. So to write this formally, the limit as x approaches 0 for the square root of x plus 1 minus 1 over x equals 1/2. Hope that helps, and that's using rationalization for finding a limit.